Hi, my name is Isabella Quintero, and I will be sharing about the acute effects of caffeine-containing supplement on bench press, leg extension, strength training, and time to exhaustion during cycle ergometry. This is a study from the Strength and Conditioning and the Department of Nutrition and Health Sciences from Lincoln, Nebraska. So the purpose of this study is to examine the acute effects of caffeine containing supplement on a 1 rep max. So I'll be referring to that as a 1 RM bench press and a 1 RM leg extension. The time to exhaustion, TTE, that'll be seen throughout the presentation as well. So time to exhaustion during cycle ergometry at a power output of 80% of the VO2 peak. And we'll go into more depth about how that works. Here's a summary of the article. So this is a double-blind crossover design. It is a placebo-controlled study. Only men were in the study, 21 untrained men. They were randomly assigned. The supplement contained 400 milligrams of caffeine, 66.7 milligrams of capsaicin extract, which increases fatty acid use, 10 milligrams of bioperine, which is black pepper extract, and 40 milligrams of niacin, a vitamin. It's essentially an energy metabolism. The placebo contained microcrystalline cellulose, and so about after 60 minutes of ingestion of the placebo or the supplement, the subjects tested their 1 RM. After 1 week of rest, they crossed the subjects and retested for the 1 RM bench, 1 RM leg extension, and their time to exhaustion on the cycle ergometer, also known as TTE. The results for caffeine had no effect on the 1 RM bench press, leg extension, or TTE cycle ergometer. Moving on. So review of the literature. A lot of the literature was actually crucial that was involved in the article. So the book, The Essential of Strength Training, is crucial because it taught the researchers and people running the experiment how to execute a strength training test, specific rest intervals. For example, like a rest interval for a strength exercise is about 2 to 5 minutes, depending on how intense the lift is or weight is. And teaching correct form to the subjects is really important as well, so the subjects don't hurt themselves while doing the research. All right, and moving on. So the caffeine and neuromuscular function article is also really important because they also study the caffeine's potential to enhance performance, and they found that caffeine has an adenosine receptor antagonist, which helps in motor recruitment, which means helping power output. So they use this article and other ones that'll be on the next slide, showing that this will potentially increase the 1 RM before they found out the results. So, like I said previously here, these other articles were other experiments that were carried out, and they were studies on caffeine and performance, and these offered value since there has been a lot of inconsistent evidence from a multitude of studies. Like, these are only 3 that I chose, and there were plenty others to choose from as well. There has been a lot of various evidence that don't really support one another, just from different training backgrounds from the participants and study approaches. For example, in this study here by Kalmar and Cofrelli, they did a study on isometric holds and caffeine, and that's completely different than a 1 RM. So again, inconsistent studies. So they thought that with the 1 RM, it should most likely help. Moving on. So the issue here is the experiment is trying to solve if caffeine has a major effect on improving athletic/exercise performance. And their hypothesis was based upon other studies. They hypothesized that the supplement would increase the participants' 1 RM bench, leg extension, and time to exhaustion on the cycle ergometer. Materials used, so subjects again were 21 untrained men in both resistant exercise and aerobically untrained as well. They had no history of day-to-day recreational activity, so only about 4 hours per week, so they were pretty inactive subjects. They did not ingest any supplements 6 weeks prior to the study, and they stuck to their original eating daily habits, so no change there. The equipment they used was an electronically braked cycle ergometer, an Olympic barbell and bench, a leg extension machine, the supplement, and of course the placebo. The methodology continued. So for experimental group, they ingested the supplement, performed the test procedure, and rested 1 week before the next test the following week. And the control group ingested the placebo, performed the test procedure, rested 1 week before the next test the following week. So as you can see, the only difference, since again this is a cross experiment, the only thing that's different is the supplement and the placebo between the two groups. So the experimental steps: a randomized, double-blinded, placebo-controlled within subjects crossover design. So again, that means that one subject will take the placebo, another subject will take the supplement 1 week, and the following week, subjects will do the opposite. So second step of the experiment, the first laboratory visit, each subject performed an incremental test to exhaustion on an electricity braked ergometer to determine their personal VO2 peak. That way, the researchers had something to go off of in order to find their 80%, so they had something to work off of. After a 1 week rest period, the subjects were randomly assigned to ingest either the supplement or the placebo. After randomization, the subjects ingested 1 dose of either the supplement or the placebo and sat quietly in the lab for about 60 minutes. This was because they needed the placebo or the supplement to kick in. So the subjects then waited a solid 60 minutes before performing the tests. The tests again were the 1 RM bench, the 1 RM leg extension, strength test, and TTE, time to exhaustion, on a cycle ergometer at a power output that corresponded to about 80% of their personal VO2 peak. Step 6, after the test, the subjects rested for 1 week without ingesting any supplement or placebo. After 1 week, the subjects ingested the opposite of what they did the previous week. Again, that explains the crossover design of the experiment. The last step, subjects retested after waiting the 60 minutes for, again, the caffeine/placebo to kick in. And here's the data. So as we can see, the graphs are predominantly the same, at the same level. So comparing the supplement versus placebo, there's no significant difference in the outcome with the 1 RM bench and the 1 RM leg extension. Moving on. So here is the supplement placebo. This is also kind of a total graph, just explaining about the average between each subject. So again, data shows that there's no significant increase comparing the supplement and the placebo subjects when testing the TTE test. Again, time to exhaustion cycle ergometer test. Moving on, here's the data for individualized subjects. The bench press is shown here and the leg extension is shown here. So again, this is showing how inconsistent this test was with the results. So 6 subjects had a greater 1RM values for the supplement than the placebo, yet the placebo had 3 subjects that were greater than the supplement, and then 12 subjects for the 1RM bench had no difference between the supplement or the placebo. So showing us that caffeine had no influence on results. And the leg extension, basically the same, just different number of subjects. 12 subjects had a greater 1RM value when taking the supplement, comparing to the placebo. 5 subjects had greater values for the placebo, comparing to the supplement, and 7 subjects had no difference in results between the placebo or supplement. Moving on. Here's the data for the time to exhaustion cycloergometer test. I apologize, I don't know why these numbers didn't show. But again, this graph is all over the place, and here it shows 11 subjects had greater time to exhaustion values for the supplement comparing to the placebo, but 10 subjects had greater time to exhaustion values for this placebo than the supplement. So again, about the same like it showed in the previous graphs. The discussion here. So the results of this investigation show that the supplement contained 400 milligrams of caffeine, which had no effect on the 1RM bench press or 1RM leg extension for strength. Showing here the results, again, were never consistent. What I highlighted here is what's very important, the range, which is the weight that was lifted. So with the supplement, the range was very low, starting at very low and going till about 18 kilos, and the range for the placebo subjects started a bit higher but ended about at the same. So not a lot of good consistent results here. And example number 2 for the results for taking 400 milligrams of caffeine had no effect on the time to exhaustion. So though this had no effect on the results between the supplement and the placebo, there have been other studies where caffeine is said to aid in long duration endurance training, so that's 30 to 60 minutes. So I do believe that more studies need to be carried out on that. Moving on. So the conclusion here, the hypothesis was incorrect according to the results from each test. Though there have been other studies on this issue, there are no set plans in the future with these researchers. I do believe that this issue will be continued throughout the future since there has not been a consistent methodology when testing this issue. And again, that is going back to different articles have done different tests. Again, a 1RM test like what they did here, isometric holds testing, long duration testing, short duration testing when intaking caffeine. So I think there needs to be more consistent studies doing the same methods, or this just continues to prove that caffeine has no major influence on performance. And I think that has a lot to do with NCAA rules continuing these research methods. But again, I do not think that caffeine, comparing to other ergogenic aids or like creatine, for instance, or steroids have much influence or have more influence compared to caffeine. And that is all. So thank you.